Okay, this is the last part of the inequalities section on chapter 3 for core 1. If we look at this in here, 3x 11 is less than 19 and 2x plus 5 is greater than or equal to 1, then what we're asked to do is find x such that it satisfies both the inequalities. The way we do this is actually quite straightforward. We actually continue on doing what we've done before, solving each equation separately, and then look at how they combine, usually on the number line. Let's have a look here. So if we start to solve them, 3x less than 30, 2x greater than or equal to minus 4, x is x is less than 10 and x is greater than or equal to minus 2. So if we look at those, we can combine those into a single inequality. So, well, it's got to be greater than or equal to minus 2, and it's got to be less than 10, so x has to be between those two values. If we drew this on a diagram like we have here, we can show that this is the inequality here of x is less than 10. This is the inequality of x is greater than or equal to minus 2. And we can see then that the two areas which overlap give us the new inequality. Note again, just to remind yourselves, that a closed circle means can be equal to, and an open circle means it is not equal to. Okay, now let's just move on to one last bit. Let's consider this as an equation. If we have something as x squared minus 4x, I'll just type this out a bit better, 4x plus 3 is less than 0. Okay, as it's a quadratic, we want it to be, we want the right hand side to be 0, left hand side to be take this quadratic, x squared minus 4x plus 3 is less than 0, and let's have a look at how we do that. Well, first of all, we go through our normal processes. We see a quadratic, what do? We factorise it. So you're looking for factors of 3 that will make minus 4 when added together. So we should be able to see that it's going to be x minus 3, x minus 1 is less than 0. Now, this is the easy part. Once we've done that solution, what we really need to do is have a look at it on the graph and see what happens. And from this we can make some generalizations, but it's always better to have a look at the graph and see what's actually happening. So we know here at x is 1, we'll say it's there, and at x is 3, we know at those 2 points the graph is 0. It's a positive amount of x squared here. Okay, positive amount of x squared here, and so the curve will have a minimum. Sorry for my drawing. Try and do this freehand. Go through there. So I get my normal parabola going through here. Go through 3 on the y-axis and up and away. Now, don't worry about the look of it. I know you would probably draw a much better quadratic than that. The important thing is here that it might look a bit better. Yeah, if I look at it here, between these 2 points, okay, in this area, just highlight it for you a little bit. In this area, there is the quadratic is less than 0, and elsewhere it's greater than 0. So we can see then, if we look back at our quadratic here, that our solution is going to be that x must lie between 1 and 3. Now we could make some generalizations, as I said earlier, from this, in that we can say, okay, if it's going to be less than 0 and it's a positive amount of x squared here, then we know that less than 0 is going to be between the two roots of the equation, x is greater, or if the quadratic is greater than 0, then x is going to be outside of the two roots. However, if it's a negative amount of x squared, the graph is obviously upside down, so we wouldn't see it like that, more like that. If there's an example of a quadratic, then we would say that between the roots here, they're greater than 0, the quadratic is greater than 0 between the roots, less than 0 outside the roots. But that's only if this was a negative amount of x squared. Okay, and really that sort of clears up the end of chapter 3. There are some really good questions in the core 2 book, the core 1 book produced by Edexcel. Particularly the exam level questions in the mixed exercise. Do work through them. When dealing with an inequality, it is actually an equation. It holds the same rules as an equation. The only difference is that if I divide or multiply by a negative, I must turn the sign around. Okay, so try and avoid multiplying and dividing by a negative number, but if you have to, so be it, and make the best of it by remembering to turn the inequality around. Okay, so that's chapter 3. That's the end of chapter 3, core 1. I hope that's helpful.